Find the equation of the tangent line to the graph of f at the indicated value of x, and we have given here a function f of x is equal to 2 times e to the power x square minus 3x plus 4, and we need to find the equation of the tangent line to the graph of this function at x equal to 0. Right, so we have given a function, we have given the x coordinate of the point of tangency, and our goal is to find the equation of the tangent line. So how do we do that? What is tangent line? The tangent line is actually, it's a straight line, right? So if that is the case, what do we do here? I mean, we have given a function, we have given the x coordinate of the point of tangency. What can we do here? Right, so what can we do? Okay, probably one of the formula that we know earlier from your college algebra or somewhere, this formula which is given as y minus y1 is equal to m times x minus x1. If you have the 1 point and the slope of the tangent line, then this point slope formula will help you to find the equation of the straight line, right? So since tangent line is a straight line, I'm trying to use the same formula here to find out the equation of the tangent line. But if I want to use this formula, you might have noticed couple of things I need to know. What are those? I need to know what is x coordinate of the point of tangency. I need to know what is y coordinate of the point of tangency, and I also need to know what is the slope of the tangent line. So I just need to fill those three unknown in here. So let's try to find each of those first. Okay, so let's do work over here. Let's first find what is x1. That means the x coordinate of the point of tangency, which is already given here. We need to find the equation of the tangent line at x equal to 0, right? So the x coordinate of the point of tangency is just 0. Now let's try to find y1 here, which is y coordinate of the point of tangency, which is y1 is equal to, how do we find the y coordinate of the point of tangency? We know that the x coordinate of the point of tangency is 0, right? So if that is the case, how do we get the y coordinate corresponding to that x value? We can just plug that number into the function. So when we do that, we'll be able to get the y coordinate of the point of tangency, right? So if that is the case, we just need to find what is the value of the function at 0. All right, so what is the function we have given? We have given the function as 2 times e to the power x square minus 3x plus 4. So if that is the case, how do you find the value of the function at 0? What do we need to do? We need to look into the function, right? And then this x we need to replace by 0. Where is x? So we have x here, right? So if that is the case, let's try to replace that by 0. So this will be, the function is 2 times e to the power, so let's replace that x by 0. So we'll have 0 square, right? And then we have what do we have? Minus 3x. So instead of that we'll have minus 3 times, replace x by 0, so minus 3 times 0. And then we also have here plus 4, right? And we just write down that constant as it is. So this is the value of the function at 0. So if you simplify this, we get this is as 2 times e to the power 0 square is 0, minus 3 times 0 is 0, plus 4 will be just 4. So 2 times e to the power 4 is the y coordinate of the point of tangency. So we have figured out x1, we have figured out y1. So we can just plug those numbers in whenever we need it. The only thing is we need is what is m. M on this formula is slope. Slope of what? Slope of some straight line. What is straight line here? The tangent line. So on that case, we need to find the slope of the tangent line at the point of tangency. So if that is the case, we know that the slope of the tangent line can be figured out by finding the derivative of the function, right? So if that is the case, then we need to find m by finding the derivative of the function. Okay, then we get the derivative, but we need to find the slope at the x equal to 0. So on that case, we need to find the derivative at 0. So this is what we need to evaluate, f prime of 0. But you might have realized if we need to compute f prime of 0, then we actually also need what is f prime of x for this function. So what is f prime of x for this function? What is f prime of x? So we have 2, right? Write down as it is, multiply by e to the power x square minus 3x plus 4. So because of the constant multiple rule, we can just find the derivative of e to the power x square minus 3x plus 4. This is what we can do. And what is the derivative of e to the power x square minus 3x plus 4? All right. If you are not sure what is the derivative of these and how to find the derivative of this function, you can look at the suggested video. But right now I can just write down the derivative here as 2 is as it is, and derivative of e to the power x square minus 3x plus 4, since we have the composite function. So by the composite rule, it will be e to the power, derivative of the exponential is e, so write that down, and we need to compose that with x square minus 3x plus 4. So let's compose that. Since it is composite, then we need to multiply by the derivative of x square minus 3x plus 4, which is 2x minus 3. Right, if you still not sure how do I get that derivative, again I suggest you the video to watch. You can see on the right top corner there is a suggested video. You can just watch that. So now this is equal to 2 times 2x minus 3 times e to the power x square minus 3x plus 4 is the f prime of x. Alright, so if this is f prime of x, then we can actually find f prime of 0, which is, we just need to evaluate this f prime function at 0. So we need to replace x completely by 0. So on the f prime, you can see here, wherever are the x, we just need to replace that by 0. So let's do that. So 2 is a constant, right? Write down as it is. And then we have 2x minus 3, right? So 2, and instead of this x, replace that by 0. So we have 2 times 0 minus 3, right? So let's write that down. And then times e to the power, right? We have x here, replace that by again 0. So we have 0 square minus, we have negative 3x, right? So minus 3 times, instead of now x, again replace by 0, right? And then plus 4. This is the value of the derivative at 0. So let's try to calculate this. So this is equal to 2 times, so what do we get here? 2 times 0 is 0, 0 minus 3 is negative 3, negative 3 times 2 will be negative 6, right? So write that down. And in a similar way, we have 0 square, which is 0 minus 3 times 0 is 0 plus 4 will be just 4. So in that case, we have negative 6 times e to the power 4 is the slope of the tangent line. So we have figured out all of the necessary information, I assume, to find the derivative of to find the equation of the tangent line. So let's work here. So this is what we need to figure out, right? So y minus y1 equal to m times x minus x1. All right, so let's try to fill the information in. So y is a variable, write that down, minus what is y1? We have computed that earlier, which is 2 times e to the power 4, write that down, is equal to what is m? So we need to write down m. M is negative 6 times e to the power 4, so negative 6 times e to the power 4, and then times x minus x1, and x1 is 0, right? So x coordinate of the point of tangency. Alright, so this is the equation of the tangent line. If you wanna rewrite this into the slope intercept form, this can be written as y equal to, now add negative 2 times e to the power 4 on the both side. When you do that, add 2 times e to the power 4 on the both side. When you do that, this can be written as negative 6 times e to the power 4 times x, right? X minus 0 is x. And then when we add 2 times e to the power 4, it will go on the other side. So this is then equal to, oh, this is already done, right? So y equal to negative 6 times e to the power 4x plus 2 times e to the power 4 is the equation of the tangent line in the sloped intercept form. Okay, this is how we can find the equation of the tangent line. So what are, just a recap, what are the major thing we are doing to find the equation of the tangent line? We use this formula, y minus y1 equal to m times x minus x1, right? Where y1, m and x were the 3 unknown we need to figure out, and we did that here. X1 is the x coordinate of the point of tangency, which is given here. To find the y1, we find the value of the function, right, at 0, right, which is just over here. We have figured that out. And to find the slope, we find the derivative at 0. For that, we evaluated the derivative here, right, and then just evaluate that derivative at 0, which we get here. Alright, so find the x coordinate of the point of tangency, y coordinate of the point of tangency, and the slope of the tangent line at that corresponding point to solve this problem.